Hello everyone, and welcome. I'm excited to kick off today's presentation on data handling. This is our first slide, titled Data Handling, which sets the stage for what we'll explore today. We'll be looking at how data is managed, processed, and utilized effectively. So, stay with me as we dive into the key concepts and best practices. Let's get started. Let's take a quick look at the contents of this section. We start with data types, which are fundamental because they define the kind of data we can work with in programming. Moving on, we have an overview of data types, giving us a broad picture of the different types available. We'll then dive into specific types, beginning with numbers, which are used for calculations and numerical data. Next, we'll explore strings, which are sequences of characters used to represent text. After that, we'll look at lists, a versatile data type that allows us to store ordered collections of items. We'll also cover list declarations, so you know how to create and initialize lists in your code. Then, we'll examine tuples, another ordered collection similar to lists but immutable, meaning they can't be changed after creation. We'll see how to declare tuples, which is essential for understanding their structure and usage. Moving forward, we'll discuss dictionaries, which are key value pairs that help us organize data efficiently. We'll learn how to declare them properly. Lastly, we'll touch on sets, which are collections of unique items, and Boolean types, which are used for true or false logic. Connecting all these concepts, understanding these data types is crucial because they form the building blocks for any programming task we undertake. Let's talk about data types. Every value we assign to a variable in Python has a specific data type. This data type is determined automatically by the Python interpreter based on the kind of data we're working with. For example, if I write a equals 12, Python recognizes that 12 is a number, specifically an integer, and assigns the integer data type to A. The key point here is that each value isn't just a random piece of data. It has a defined type that Python keeps track of behind the scenes. Understanding data types is fundamental because they influence how Python handles and manipulates the data. So, as we go through this presentation, keep in mind that Python's ability to identify and work with different data types is a core part of its flexibility and power. All right, let's take a closer look at the data types overview. First up, we have numbers. These are the most basic data types, used to represent numerical values like integers or floating point numbers. They are fundamental because they allow us to perform calculations and store quantitative data. Next, we have tuples, which are similar to lists but are immutable, meaning once you create them, you can't change their contents. Tuples are useful for fixed collections of items that shouldn't be modified. Moving on, Boolean values are either true or false, and they're essential for logical operations and decision-making in our programs. Then, we have strings, which are sequences of characters used to represent text, like names or messages. Strings are incredibly versatile, and you'll see them everywhere in programming. Next up are dictionaries, which store data in key-value pairs, making data retrieval efficient. Think of them as a real-world dictionary where you look up a word and get its definition. After that, we have lists, which are ordered collections that can hold different types of data and are mutable, meaning we can change their contents. Lastly, sets are collections of unique items, which are great for removing duplicates and performing mathematical set operations like unions or intersections. When we connect all these data types to the overall theme, it's clear that understanding them is crucial because selecting the right data type directly impacts the efficiency and clarity of our code. Each type serves a specific purpose, and mastering them gives us more power and flexibility in programming. Now let's take a look at data types, starting with numbers. When we talk about numbers, there are different kinds, and one interesting type is called complex numbers. Complex numbers are a bit different from the real numbers you're used to. They include a real part and an imaginary part. For example, 12 plus 4i. The I here represents the imaginary unit, which is the square root of -1. This might sound a bit abstract, but complex numbers are incredibly useful in fields like engineering, physics, and even signal processing. They help us handle equations that can't be solved with just real numbers. So, understanding complex numbers expands our ability to work with a wider variety of mathematical problems, which ties right into our overall theme of exploring different data types and their applications. Let's talk about strings in programming. A string is essentially a collection of characters or a sequence of characters that we use to represent text. When we assign a string to a variable, we need to enclose it in quotes. For example, if I want to store the name Deepali, I can use single quotes like this. Deepali, or double quotes. Deepali. Both are acceptable, but it's important to be consistent in your code. When working with strings, you can also assign them to variables, such as a equals Deepali. This makes it easy to refer to that text later in your program. Now, sometimes you might want to include multi-line text or longer blocks of text. In such cases, you can use triple-double quotes like this. This allows you to create strings that span multiple lines, which is really useful for formatting or large text blocks. Understanding how to handle strings properly is fundamental because they are everywhere, whether you're displaying messages, storing names, or processing text data. Mastering these basics helps you write clearer, more effective code that works with text efficiently. Let's take a closer look at the list of key features. First, we have the concept of an ordered sequence, which means that the items are arranged in a specific order. This is important because it allows us to process or access items in a particular sequence. Next, a flexible data type is essential, as it means we can store different kinds of data within the same list. This flexibility makes lists very versatile. Then, we see that lists are changeable, meaning that individual items can be altered or updated as needed. This dynamic nature is a big advantage in many programming scenarios. Moving on, lists can contain various items, which can be either homogeneous, meaning all the same, or heterogeneous, meaning different types. This diversity allows lists to be used in a wide range of applications. Finally, it's worth noting that lists are widely used across many programming languages, making them a fundamental tool you'll encounter often. So, in summary, lists are an ordered, flexible, and changeable way to store collections of items, whether they're all the same or different, and their widespread use highlights their importance in programming. Now, let's take a closer look at the list declaration. In this example, F is a list that contains 3 different items: the number 1, the number 2, and the name Deepali. Notice that all these items are enclosed within square brackets, which is a key feature of list notation in programming. The items are separated by commas, acting as delimiters to distinguish each element within the list. This structure allows us to store multiple related items together in a single variable. Understanding lists is fundamental because they enable us to organize and manage collections of data efficiently. They are versatile and widely used in programming to handle sets of values, whether numbers, strings, or even more complex objects. In the context of our overall theme, grasping how lists are declared and used helps us write clearer, more effective code that can manipulate groups of data seamlessly. Now let's talk about tuples, which are a special kind of ordered sequence. They are often used to protect the data, meaning once you create a tuple, it stays the same. One key point to remember is that tuples are unchangeable. You can't alter them after they've been created. This makes them useful for ensuring data integrity. Tuples can contain items that are either homogeneous, meaning all of the same type, or heterogeneous, meaning different types. This flexibility allows tuples to be used in a variety of situations. Understanding how tuples work helps us see their role in managing data safely and efficiently within our programs. Let's take a closer look at how we declare tuples. As you can see here, we have an example. F equals open parenthesis, 1, 2, and Deepali, then close parenthesis. The commas act as separators between the items, making it clear where one element ends and the next begins. It's important to note that all the items are enclosed within parentheses, which is a key characteristic of tuples. This structure helps us organize different types of data, like an integer, a float, and a string, all in one ordered, immutable collection. Understanding this declaration is fundamental because tuples are widely used for grouping related data efficiently, and recognizing their syntax helps us work more effectively with Python. let's take a closer look at the dictionary declaration. Essentially, it contains key value pairs, which means each key is associated with a specific value. These pairs are enclosed within curly brackets, giving the dictionary its structure. For example, in this case, we have F equals Rohan. Cycle, Satyam, car. Here, Rohan is a key linked to cycle, and Satyam is a key linked to car. One important point to remember is that each key value pair is separated by a comma, which helps distinguish where one pair ends and the next begins. This structure allows dictionaries to store related data efficiently, making retrieval quick and straightforward. Understanding this concept is fundamental as we explore how data can be organized and accessed in Python, which ties into the overall theme of data management and programming. Let's talk about dictionaries, which are a fundamental data structure in programming. They store data as an unordered sequence, meaning the items are not kept in a specific order. This might seem simple, but it's incredibly powerful. Dictionaries are used for code optimization because they allow us to quickly access data without having to sift through everything. They contain key value pairs, where each key uniquely identifies a value. This setup makes retrieving data really efficient. Just use the key, and you get the value instantly. Dictionaries are especially useful when working with huge amounts of data. Instead of searching through a long list, you can directly access the needed information with its key. This makes your programs faster and more efficient, which is critical when handling large datasets or complex applications. Overall, understanding dictionaries helps us write more optimized, scalable code, an essential skill as we continue to work with bigger and more complex datasets. Let's talk about sets, which are well-defined collections of items. When I say well-defined, I mean that we know exactly what items are included, and there's no ambiguity. Sets are usually enclosed within curly brackets like this. For example, if I have the set F equal to 1, 2, dpoly, it contains different types of items, an integer, a floating point number, and a string. Notice how we separate each item with a comma. That's the key to clearly listing elements in a set. Commas act as separators, making it easy to distinguish one item from another. Understanding sets is fundamental because they help us organize data and work with collections in a structured way. So, whenever you're defining a set, remember, it's a clear, enclosed collection of items, separated by commas, and can include different types of data. This concept forms the foundation for many other topics we'll explore in the presentation. Now, let's talk about Boolean values, which are fundamental in programming when we want to work with true or false conditions. In this slide, we see that Boolean values are declared with the keywords true or false. For example, we might write bool1 equals true, indicating that this variable is set to true. Similarly, bool2 could be set to false. These Boolean variables are essential because they help us control the flow of our programs through conditions and decision-making. Remember, understanding how to declare and use Boolean values is a key step in writing logical and efficient code. It ties into the overall theme of programming logic and making our programs respond correctly to different scenarios.